Hi, my dear. Uncle Jimmy. How are you? My dear, continually chapter 9. Flow in cross conduits under pressure. Part 5. Flow through pipe network. Flow through pipe network. Pipe network is a connected pipe in a system forming several loops or circles as shown in the enclosed figure. Determination the flow discharge in each path in that complex network is very important here, as is case. Accordingly, there are some conditions must be following up a case of pipe network as shown in front of you. Follow it, my dear, by yourself. It is so easy and clear. Mathematical calculations of head losses in each pipe, which concluded such as head losses equal K multiplied by Q squared. Coefficient of losses K can be calculated for each pipe in the network in each loop. Head losses for any pipe in loop will be positive when the flow trend inside it is in clockwise direction, while be negative if the flow direction is in anti-clockwise. Generally, pipe network problems are difficult. Hence, Hardy cross method is the one which depends on head balance and is commonly used at these cases. As shown in front of you, my dear, follow all the components by yourself. Look, my dear, the calculation of correction vector delta Q as shown in front of you. Example: calculate the discharge in each pipe of irrigation network shown in the enclosed figure. The network consists of 7 pipes in 2 loops. Both the inflow and outflow discharge at each node, in addition to K values for each pipe, are shown also in front of you. Solutions example. First trial. Mathematical calculation of both KQ squared and do KQ. Hence, you can calculate the correction vector delta Q as shown in front of you in both loops AFCP and FEDC. Look, my dear, the head loss is positive in pipeline AF and FC in loop AFCP, referring to the flow direction in these pipes are in clockwise, while the head losses is negative in pipelines AP and PC in the same loop AFCP, referring to the flow direction in these pipes are in anticlockwise. Correction vector delta Q is negative also in loop AFCP. Hence, this value should be subtracted from the flow in clockwise direction, while added to the flow in anticlockwise direction. Accordingly, the corrected Q values at first trial for loop AFCP can be concluded as shown in front of you. On the other hand, the head loss is negative in pipelines FC and CD in loop FEDC, referring to the flow direction in these pipes are in anticlockwise. Correction vector delta Q is positive in loop FEDC. Hence, this value should be added to the flow in clockwise direction, while be subtracted from the flow in anticlockwise direction. Accordingly, the corrected Q values at first trial for loop FEDC also will be concluded as shown in front of you. Figure showing the correction discharges distribution in pipeline at first trial, referring to delta Q values in both loops of the example. Mathematical calculation of both KQ square and 2KQ in the second trial for both groups AFCP and FEDC. Hence, you can calculate the correction vector in both loops as shown in front of you. Look, my dear, the correction vector delta Q is positive in loop AFCP. Hence, this value should be added to the flow in clockwise direction, while subtracted from the flow in anti-clockwise direction. Accordingly, the corrected Q values at second trial for loop AFCP will be shown and calculated as in front of you. While, on the other hand, the correction vector delta Q is negative in loop FEDC. Hence, this value should be subtracted from the flow in clockwise direction, while be added to the flow in anti-clockwise direction. Accordingly, the corrected Q values at second trial for loop FEDC will be concluded as shown in front of you. Figure showing the correction discharges distribution in pipelines at second trial, referring to delta Q values in both loops in the example. Third trial, mathematical calculation of both KQ square and 2KQ for both loops AFCP and FEDC. Hence, calculation the correction vector delta Q for both loops can be concluded as shown in front of you. Look, my dear, as the correction vector delta Q is too small for both loops, so these conditions are applied. Hence, an additional trial is not necessary absolutely. Accordingly, the corrected discharge distribution in the pipelines for both loops would be concluded as shown in front of you. Finally, figure showing the final discharge distribution in the pipelines in both loops. Goodbye.